Okay, so we're looking at solving exponential equations. So we are going to do this. There are a couple of different methods. We're just going to use the method of using logarithms to solve. So we have 2 to the power of x is equal to 3. So a couple of things to notice. I have a single base on either side, so I don't have anything being multiplied to anything. I have a base with an exponent and a base technically with an exponent of 1. So I am going to go ahead and just apply the natural log to both sides. So I'm going to take ln of 2 to the power of x equals ln of 3. So I applied the natural log to both sides. Now, why in the world would I do that? So if you recall, we have a property that says if I have the argument of a logarithm with an exponent, I can take that exponent and pull it out as a coefficient, which is great because now this is essentially just a linear equation. I want to get x all by itself. The natural log of 2 is a number, which we're going to see in just a second. I can just plug that into my calculator and get it. So I have x times a number. So to get x all by itself, then I'll just divide by that number. So I'll divide both sides by the natural log of 2. My natural log of 2 on both sides will cancel. So I get x is equal to the natural log of 3 over the natural log of 2. This is what we call the exact, the exact answer, which in some cases you will be asked for. So if you're asked for the exact answer, bam, that's it. The approximate answer is what we get when we plug this into the calculator. So note real quick, I used the natural log, ln. You could have used log, just log with the base of 10 in the same exact way, and you would end up with the same exact answer, except you would have log of 3 over log of 2, but it's going to give me the same answer as the natural log. So whichever one you want to use is fine. We're going to end up with the same answer. So again, this is the exact value, and now I want to find the approximate value rounded to 2 decimal places. So I'm going to take my calculator, whatever calculator you may have. So I used ln, I used the natural log, so I need to find on my calculator the ln. So here is the ln. So I have ln of 3 over ln of 2. So ln of 3, or natural log of 3, divided by the natural log of 2. Notice I did close my parentheses, so my calculator knows I'm dividing the natural log of 3 by the natural log of 2. And I end up with this long number, but I wanted to round to 2 decimal places, so I get 1.58. So x is approximately 1.58. That's rounded to 2 decimal places. Pay attention to what the question's asking you for. Here's exact, here's approximate to 2 decimal places. So just round appropriately for whatever you're asked for. All right, so that's the basic gist of it. The problems do get a little more involved, for lack of a better word. So let's look at one that's a little more involved. So let's say we have 7 to the power of 2x plus 5 is equal to 9. So again, notice that I have a single base on either side. There's not anything being multiplied to any of my bases. So I'm good to go. I can go ahead and directly take the natural log of both sides. So I'm going to take the natural log of 7 to the power of 2x plus 5 and the natural log of 9. And now again, we're going to use the property that says I can take the exponent out as a coefficient. So be careful with parentheses here. 2x plus 5 becomes my whole coefficient. So I have 2x plus 5 times the natural log of 7 equals the natural log of 9. And again, this is a linear equation, so I want to just get x all by itself. We see that we're multiplying by the natural log of 7, so to get rid of that, I can divide both sides by the natural log of 7. On the left, the natural log of 7 cancels, so I get 2x plus 5 equals the natural log of 9 over the natural log of 7. The right side looks funky, and that's all right. All of your exact answers will. So on the left, this should look pretty familiar. I'm trying to get x all by itself, so what is it that I need to do? Hopefully The answer is subtract 5 from both sides and then divide by 2. So if I subtract 5, it looks like that. And if I divide by 2, then I get this big old funky answer. So x is equal to the natural log of 9 over the natural log of 7, all of that minus 5, and all of that divided by 2. So this is one form that the exact answer could take on. We could use different properties to manipulate that, make it look differently. If we come back up here, the natural log of 7 was multiplied, so I could have distributed and solved it that way. So if you, as long as your algebra is correct, your final exact answer may look a little bit different than what I have here if you work this out on your own. And that's okay. There's different variations, different properties that we could use to make it look differently. So just be mindful of that as you work through problems and if you watch any other videos or anything like that. So here's my exact answer. A lot of times, again, I'm going to be asked for the approximate, so I'm going to go ahead and plug that into my calculator. So I have the natural log of 9 divided by the natural log of 7. And then I want to subtract 5. And divide by 2. So I get negative 1.9. If I'm rounding to 2 decimal places, then it'll be negative 1.94. So here's exact. My approximate is negative 1.94. All right, so one more problem, because of course it can be a little bit more involved. So let's say, last example, I have 3 times e to the x minus 8 is equal to 4. So if you recall in the first 2 examples, I was like, look, nothing's being multiplied to the bases. Well, now e and 4 are my bases, but this base is being multiplied by 3. So I could go ahead and just take the natural log here, but then I'm going to have to use properties to separate these so I can pull the exponent as a coefficient. An easier way to get rid of that is just go ahead and divide by that 3. Saves you a couple of steps. So 3's cancel. I get e to the power of x minus 8 is equal to 4/3. Now I have a single base on either side. Makes things a little bit prettier. So I'm going to take the natural log of both sides. Use the property to pull my coefficient out. So x minus 8 times the natural log of e equals the natural log, or 4/3. And kind of like the last example here, the natural log of e is being multiplied to x minus 8, so I'm going to divide by the natural log of e on both sides. So I get x minus 8 is equal to the natural log of 4/3 over the natural log of e. And last, just add 8 to both sides, so I get x is equal to the natural log of 4/3 over the natural log of e, and all of that plus 8. So again, here is my exact answer. Some of you may notice, because of the properties of logarithms, remember that the base of the natural log is e, and here my argument is e. Anytime the base and the argument are the same, then that logarithm simplifies to 1. If you saw that, you could have simplified it back here and just added 8. That would have been fine. If you didn't, it's fine. This is still technically the exact answer. So I'm going to go ahead and find the approximate, again, to 2 decimal places, but it could be asking you for 3, 4, 5, 17, whatever it may want. You just need to know how to round. So the natural log of 4/3, get that where the glare is not on it, so the natural log of 4/3 divided by the natural log of, we can do e, that's fine, even though I know that's 1, plus 8 gives me 8.287 something something. So if I'm rounding to 2 decimal places, I would get 8.29. So there's my exact, and again, the approximate, just depending on what you're asked for.